Check it out. Here we are in the next video, and we are going to cover the domain controller. Yeah, it's a big topic, so let's get into it. A domain controller is a type of server that processes requests for authorization from users within a computer domain. Domain controllers are most commonly used in Windows Active Directory, AD domains, but they're also used with other types of identity management systems. Domain controllers duplicate directory service information for their domains, including users, authentication credentials, and enterprise security policies. Domain controllers restrict access to domain resources by authenticating user identity through login credentials and by preventing unauthorized access to those resources. Domain controllers apply security policies to requests for access to domain resources. So, for example, in a Windows AD domain, the domain controller draws authentication information for user accounts from AD. The domain controller can operate as a single system, but they're usually implemented in clusters for improved reliability and availability. For domain controllers running under Windows AD, each cluster comprises a primary domain controller, PDC, and one or more backup domain controllers, or BDC. In Unix and Linux environments, replica domain controllers copy authentication databases from the primary domain controller. So domain controllers control all domain access, blocking unauthorized access to domain networks while allowing users access to all authorized directory services. The domain controller mediates all access to the network, so it's really important to protect it with additional security mechanisms, like a few of these: firewalls, secured and isolated networks, security protocols, and encryption to protect stored data and data in flight. Restricted use of insecure protocols, such as remote desktop protocol on controllers. Deployment in a physically restricted location for security. Expedited patch and configuration management. Blocking internet access for domain controllers. So domain controllers control all access to computing resources in an organization, so they must be designed to resist attacks and to continue to function under adverse conditions. Domain control is a function of Microsoft's Active Directory, and domain controllers are servers that can use Active Directory to respond to authentication requests. Now, experts advise against relying on a single domain controller, even for smaller organizations. Best practices call for one primary domain controller and at least one backup domain controller to avoid any downtime from system unavailability. Another best practice would be to employ each domain controller on a standalone physical server. Now, this includes virtual domain controllers, which should be run on virtual machines, or VMs, running on different physical hosts. You see how that works. Domain controllers can be deployed on physical servers, running as VMs, or as a part of a cloud directory service. All right, so let's have a look at some of the steps for setting up an AD domain controller. You've got domain assessment. So this is the first step in setting up a domain controller, is to assess the domain in which the controller is going to be set up. Right? The assessment includes determining what types of domain controllers are actually needed, where they're going to be located, and how they interoperate with existing systems in the domain. New deployment or addition. So whether you're planning for a new deployment of AD domain controllers or adding a new controller for an existing domain, determine the domain controller location as well as the resources needed to run the centralized domain controller and any other virtual domain controllers. Security by design. See, it's imperative to secure a domain controller from internal or external attacks. Also, design the domain controller architecture to be secure from service disruptions, from loss of connectivity, loss of power, or system failures. The specifics for setting up and configuring AD domain controllers can vary depending on the version of Windows Server in use on the domain. But some of these options could be available when you're setting up a domain controller with AD. Domain Name System Server, or DNS server. So here the domain controller can be configured to function as a DNS server. Dell recommends configuring at least one domain controller as a DNS server. Global catalog capabilities. The domain controller can be configured to use global catalog, which enables the controller to return AD information about any object in the organization, regardless of whether the object is in the same domain as the domain controller or not. Very useful for large enterprises with multiple AD domains. Read-Only Domain Controller, RODC. Domain controllers used in branch offices or in other circumstances where network connectivity is limited can be configured as read-only. Directory Services Restore Mode, DSRM. So DSRM provides the option to do emergency maintenance, including restoring backups, on the domain controller. A DSRM password must be configured, though, in advance. Let's have a look at some of the differences between Active Directory and a domain controller, shall we? Yes, we shall. So the domain controller, right? Every system has local accounts, and IT administrators need to manage and configure such user accounts centrally. And centrally managed accounts can also access network resources. So to ensure authenticated accounts use the network resources, domain controllers verify and validate them. This helps protect your network from unauthorized user access, as well as ensuring only relevant users have that network access. Active Directory was introduced by Microsoft for centralized domain management. So this database enables users to connect with network resources to get their work done. It can store huge volumes of data as objects organized as forests, trees, and domains. It also includes other services such as permission access rights management, single sign-on, you've seen it as SSO, security certificates for public key cryptography, and lightweight directory access protocol, or LDAP. Active Directory, though, is a framework that manages several Windows Server domains. In contrast, a domain controller is a server on Active Directory to authenticate users based on centrally stored data. Each Active Directory forest can have multiple domains. The role of domain controllers is to manage trust among the domains by granting access to users from one domain to another via a proper security authentication process. System administrators can also set complex security policies via domain controllers. So that's good, right? Yes. Anyway, let's talk about the advantages. A domain controller controls Active Directory administration privileges and limits domain user accounts, right? The domain controller ensures every computer connected to a network is authorized before granting access rights to sensitive files. It carefully reviews user accounts and provides administrative privileges and access to only those who need them to perform their job functions. Makes sense, right? It also ensures user accounts are protected with robust passwords. It's also going to help avoid operator error data breaches. Insecure passwords are one of the leading causes of data breaches. The data controller provides network-wide security policies, such as those that require users to set a unique and robust password. It also manages the network centrally. Managing and configuring devices individually is a very time-consuming task. A domain controller can save cost and time to set login and security parameters for devices from a centralized server. Additionally, domain controllers allow automatically installing network printers on your system as soon as they join your domain. You can centrally manage, pause, command, or restart printing devices all across your network. Also allows sharing of resources. Domain controllers enable sharing of resources as all the devices are connected centrally. You can set login-specific access privileges and access any computer or device. So this helps reduce the cost required to purchase new printers, computers, whatever else you're going to be purchasing. Preventing unauthorized user access. So domain controllers have set security controls to prevent user accounts from accessing your network with too many failed login attempts. You can disable user accounts immediately when an employee leaves an organization, require login credentials for lock screens, as well as restrict USB access based on user permissions and access rights. But sure enough, advantages always come with a few disadvantages. Domain controllers have complex structures and may be difficult for a single user to understand. It requires proper planning to set up a domain controller for your network. It also requires regular monitoring and management to ensure security policies as well as administrative privileges. They got to be up to date. It becomes a target for cyber attacks, and it may actually be easily hacked. The entire network is dependent on the domain controller's uptime. So what do you say? That's all about the domain controller. I know you learned a lot. We're going to take that forward as we go on to the next video. I'll see you then.